Okay, so we finally get to talk about the mixture. So the past three videos have been focused on making the standards, analyzing the standards, and calculating the actual molar absorptivities that I need to begin using in the actual lab procedure itself. So we have taken a look at two lambda maxes really now, right? We've taken a look at caffeine and we've taken a look at aspirin. So we've got a lambda max of 229 and we've got a lambda max of 272. And now I'm given the job of taking this mixture that has aspirin and caffeine both in it and figuring out what are the concentrations of each one of those pieces and parts. What's the concentration of aspirin? What's the concentration of caffeine? And I want to do that in one run, and UV-Vis will allow me to do it. Okay, so I need to basically take the mixture now, and I need to take this mixture and I need to run it at 229 and get an absorbance, and I need to run it at 272 and get an absorbance. The reason is because aspirin is in the sample and I need to be running it at aspirin's wavelength. Caffeine is also in the sample and I need to be running it at caffeine's wavelength. So that's the reason that we have to run the mixture at two different wavelengths, because I've got two components that I'm looking for, and each one has a lambda max that's associated with it. Okay, so that's the first thing that I'm going to do. So step number 4 now is to analyze, let me spell this correctly, analyze the mixture. So I'm going to get an absorbance at 229, and then I'm going to get an absorbance at 272. So I take this mixture that's given to me, I do a go-to feature at 229, and the absorbance that I get maybe is 0.301. And then I do the go-to feature and I type in 272 onto the machine, and it goes to 272 and it gives me an absorbance, and that absorbance is 5.517. Okay, so these are the absorbances due to the mixture. Okay, so now let's start plugging in some of the other data that I know. All right, so at 229 and at 272. Well, I've got two components here, right? I've got aspirin and I've got caffeine. Okay, well, aspirin is 229. That was the lambda max for that, right? And we calculated a molar absorptivity. Aspirin's molar absorptivity at aspirin's wavelength was 866. We did that previously. And then we did that for caffeine too. We took caffeine. Caffeine's lambda max is 272. So we calculated the molar absorptivity for that, and we didn't get 8510 that the book gave us. We got 8042 instead. Okay, so there's the molar absorptivities of aspirin at aspirin settings and caffeine at caffeine settings. Okay, so from this point, we then turned around and took aspirin and ran it at caffeine settings. We took aspirin and we ran it at 272 and we calculated a molar absorptivity. And that molar absorptivity was 44. And we did the same thing for caffeine. We took the caffeine standard, ran it at caffeine settings, but we also took caffeine and ran it at the aspirin settings at 229. And we took that absorbance and we calculated the molar absorptivity and we got 624. Okay, so these are molar absorptivities for aspirin at aspirin and aspirin at caffeine. And this is the molar absorptivity of caffeine at aspirin and caffeine for caffeine. Okay, so there's all of our data now into one table. So from this point, we need to take a look at the equation that we need to be leading up to. And this matrix equation looks something like this. Kind of horrible looking, but it's not too bad. Absorbance, absorbance double prime, EX prime, EX double prime, and then E prime Y, E double prime Y, E prime Y, E double prime Y, and that will allow me to solve for the X component. And then I do the same thing here for the Y, but it's kind of flipped around a little bit. This is EX prime, EX double prime, EX prime, EX double prime. And this is absorbance prime, absorbance double prime, E prime Y, E double prime Y. Okay, so these are the equations that I need to use in order to solve for the the concentrations for aspirin and caffeine. So up here at the top, it doesn't really matter which one is X and which one is Y. I'm just going to put this one as X just because that one shows up first, and then I'm going to put this one as Y but just because that shows up second. If you want to put aspirin for the Y part and caffeine for the X part, be my guest. You'll end up with the same number no matter what you do. So I'm just going to kind of go in order. There's the X component, there's the Y component. We also need to start talking about my absorbance prime and my absorbance double prime. Again, it doesn't really matter as long as you're staying consistent. So I'm just going to say this is the prime and this is the double prime, but just because that's the way I wrote them down on the sheet of paper. Okay, so now I can start plugging in some of these numbers. And some of these numbers that I can begin to plug in are kind of simple. So if I look at my absorbance prime, here is my absorbance prime. That's 0.301. Okay, so that was an easy one, right? 0.301. Here is my absorbance double prime, and there's my absorbance double prime in the matrix. So my absorbance double prime is 0.517. And you know, I'm going to go ahead and start working on this matrices over here as well. You might as well kill two birds with one stone. Absorbance prime at the top, absorbance prime down here at number 2. So I do the same thing there. Absorbance prime, 0.301. Absorbance double prime, 0.517. Alright. Now I need to take a look at this top piece, and this is absorbant or molar absorptivity at the prime. Well, my prime is at 229, right? So this is molar absorptivity, which means here's my prime. These are molar absorptivities, so which one of these do I need to use? And it tells me it's of your Y component. Okay, so my Y component is of caffeine, and that was at 624. So my E prime Y is 624. Well, that's E prime Y there. And E prime Y is also here, and E prime Y is also there. So I can put that into 3 spots now. So 624, 624, and 624. Now this is E for caffeine at my second absorbance. That's how I read that, right? So this is the molar absorptivity of caffeine, because it's the Y one, at my second absorbance, which is here, and that's 8042. So I can go through. Here's E double prime Y, E double prime Y, and E double prime Y. And all of those get changed to 8042s. Alright. Now I need to take a look at this piece of the matrix. Molar absorptivity of X. Well, X was aspirin. So molar absorptivity of the aspirin at the first absorbance level. So here's my A prime. So it needs the molar absorptivity, that's 866. Okay, so there's EX prime, and then here's EX prime, and there's EX prime. So I need to go through and put in 866 at each one of those spots. Okay, so now next, molar absorptivity of X double prime. Molar absorptivity of aspirin at the second absorbance level. So here's the second absorbance, 272. That was 44. Here's the X component, that was aspirin. So EX double prime, EX double prime, EX double prime. So I'm going to go through and I'm going to put in 44 here, 44 there, and 44 here. Okay, so now that I've solved, or now that I've plugged in the numbers for the actual matrix itself, I can now turn around and begin to simplify this matrix up a little bit. So up at the top, again, to solve for the matrix, I just cross multiply. So 0.301 times 8042, and then I'm going to subtract that from 0.517 times 674, and I'm going to get 2072.184 divided by, and I do the same thing at the bottom, 866 times 8042 and 44 times 624. So 866 times 8042 minus 44 times 624. And I get 6936916, and I do 272.184 divided by 6936916, and I get 2.98 times 10 to the negative fourth molarity. Now, this is the concentration for the X component, and if I go up to my table, my X component, if I look, is the aspirin. So this is the concentration for aspirin in the mixture. Okay? And then for Y, I do the same exact thing. There's no difference in it. So we can solve that one really quick if we need to, just to make sure you're getting the same answer as I am. So 866 times 0.517. And I'm going to subtract that from 44 times 0.301, and I get 434.478. Now this is going to be the same number on the bottom, right? 866, 866, 44, 44, 624, 624, 8042, 8042. The matrices are the same denominator. So I'm going to divide that by 6936916, and I hit enter, and the concentration for my caffeine is 6.26 times 10 to the negative fifth molarity. And this is the concentration of caffeine in the mix.